A review on Parkinson's disease diagnosis using machine learning techniques. Abstract: Parkinson disease is a neurodegenerative disorder that affects nervous system, and the root cause of it is falling rates of dopamine levels in the forebrain. It is a chronic degenerative disease with progressive illness, which means it develops new symptoms over time. This happens with progressive neuronal loss in the substantia nigra of brain. People with PD cannot do their works as a normal human. Though clinical assessments considered ample amount of data that include various features, sometimes it is hard to decide whether a person is suffering from PD or not based on the type of data. Feature selection methods help to solve this issue. Various methods are developed, proposed, and analyzed to detect the Parkinson disease, given the required data. This paper is a survey of predicting Parkinson disease using machine learning algorithms, various new technologies applied, and their accuracies achieved. Keywords: PD, Parkinson disease, dopamine, SVM, support vector machine, KNN, K nearest neighbor, and artificial neural network. 1. Introduction. Parkinson disease mainly affects central nervous system and is observed to be affected on many people globally. Most of the people suffering with PD are observed to be physically and emotionally draining. They even feel depressed, trouble concentrating on things, painful spasms, etc. PD has a large spectrum of clinical features ranging from motor to non-motor symptoms. Some of the motor symptoms are hypophonic speech, rigidity, resting tremor. Non-motor symptoms are as hallucinations, depression, constipation, sleeping disorders, cognitive impairment, and impulse control disorders. Non-motor symptoms show sickness than motor symptoms. 1,3. Most of the cases, physicians find it difficult to envisage whether a given patient is already affected by the disease or is expected to develop the Parkinson's disease. 7. To conquer this, development of some computing model must be done that evaluates and summarizes the data of a given patient and predicts with adequate accuracy where he/she will have development of PD. Most of the PD patients are observed with symptoms called voice impairment, which is known as dysphonia. There are several measures related to dysphonia, out of which voice-related problem can be used to assess the patients at various stages. 14. This paper is a survey of prediction of PD using machine learning and deep learning techniques that generated good models and potency of those algorithms in terms of accuracies achieved, also about different methodologies applied. 2. Literature survey. 2.1 Importance of voice data. Speech or voice data is assumed to be 90% helpful to diagnose a person for identifying presence of disease. In general, person with PD suffer from speech problems, which can be categorized into 2, hypophonia and dysarthria. Hypophonia indicates very soft and weak voice from a person, and dysarthria indicates slow speech or voice that can hardly be understood at one time, and this causes because of damage to central nervous system. So, most of the clinicians who treat PD patients observe dysarthria and try to rehabilitate with specific treatments to improvise vocal intensity. 2.2 Survey carried out for the diagnosis of PD with different algorithms and approaches. Several strategies are recorded for early detection of PD based on the different ML techniques. But accuracy in detection and classifying within the time is very important, or else it causes development of more symptoms. There are different kinds of data: brain MRI images, voice data, posture images, senior captured data, handwritten data, using which we can predict whether person is having PD or not. Out of all those, speech or voice data helps in identifying PD accurately. Eduardo Tolosa et al. Proposed a twofold fully automatic approach with 3D images has shown promising results in their experimentation. 4. Max A. Little et al. Presented a new dysphonia measure, pitch period entropy, PPE, and used a kernel support vector machine and has achieved classification accuracy of 91%. 10. Rainer Schoenweiler et al. Identified a different approach which used voice analysis with N and got good results, but observed that cost effectiveness remains to be a challenge. 5. Marius Ene et al. Suggested NN-based approach with 3 types of internal methods and discriminated persons having PD with healthy persons. 7. David Gill A., Magnus Johnson B. found that with a smaller number of neurons at hidden layer both training set and test sets performed poorly. With higher number of neurons, the training set performed well with high risk of overfitting. The ideal solution for this layer was found to be 13 neurons 8. Ipsita Bhattacharya et al. Identified the ROC curve variation and identified that values of TP and FP rates show changes while increase in the CV folds 13. Freddie Astrom et al. Proposed unique approach of parallel neural networks, and then outcome of each neural network is assessed by using a rule-based system for the decision. During the training process, data that is not yet learned of each neural network is collected and applied in the training set of the later neural network. This helped to increase prediction accuracy. 14. Athanasios Tsanas et al. Developed a novel algorithm based on speech signals, but it's questionable as most of the features are not considered here, only 10 features are used. 15. Huiling Chen et al. Proposed FKNN-centered system using a tenfold cross-validation method. 17. Mohammed S. Islam et al. Has compared various ML techniques based on their performance accuracies in determining whether person is having PD or not, and mentioned that new classifier may be built to get better accuracies. 18. Bopenga et al. Suggested computer-aided analysis with image data and used BrainLab software for processing the images and calculate thickness of the cortex, volume of gray matter, and surface area of the cortex on each region of interest, ROI. Use of multilevel ROI-based features improved the classification performance. 19. Dirya Avsi and Akif Dogan-Tekin proposed another approach using genetic algorithm wavelet kernel extreme learning and achieved good accuracy results. 22. R. Prashant identified that multimodal features can be used to predict PD in earlier stage. 23. Satyabrata Ike proposed a unique approach by using genetic algorithm and PCA as feature selection methods and applied 7 ML algorithms for classification, that saved time and productivity while doing pattern classification with 2 categories such as PD and not PD. 25. Leandro A. Passos compared ResNet 50, Optimum Path Forest, OPF, Class I.ER with support vector machines, SVM, and Bayes and achieved 96% of identity.cation rate. 37. Deepak Gupta followed a different approach cuttlefish algorithm and used for feature selection. Different fitness functions approximations are used to improve cuttlefish algorithm and is termed as optimized cuttlefish algorithm, OCFA. Decision tree and k-nearest neighbor classifiers are applied and achieved 94% of accuracy in detecting PD-affected patients. 36. Salama A. Mustafa proposed multiple feature evaluation approach, MFEA, of a multi-agent system. 2. Implementation of 5 classification schemas which are decision tree, random forests, neural network, naive Bayes, and support vector machine on the Parkinson's diagnosis before and after applying their approach, and 3. Author approach witnessed the following average rate of accuracies. Decision tree achieved accuracy of 10.51%, naive Bayes shown 15.22%, neural network is found with 9.19%, random forests and SVM performed with 12.75% and 9.13% respectively. 34. It is important to note that, out of all ML techniques, an SVM classifier are used most of the proposed algorithms to aid faster and accurate the prediction. As per the survey, we observed that most of the models used voice/speech data for efficient diagnosis of the disease, and because it is preferred by most of the therapists to consider voice data as relevant feature. 3. Architecture of N. The following figure represents architecture of artificial neural network with an input layer, hidden layer, S, and an output layer. Number of hidden layers for each network varies from one another. Every circle in the above network represents a neuron at which the inputs and corresponding weights are processed layer by layer. Input layer. An input layer accepts large volumes of data as input to build the neural network. The data can be in the form of text, image, audio, etc. In general, the input layer contains features of the dataset. Each node of input layer in the above architecture represents one feature. Hidden layer. Every hidden layer receives the input feature along with their weights, where weights of every feature indicates their contribution towards the decision or prediction. Hidden layer processes the data at each node by performing complex computations and helps in feature extraction. Nodes at first hidden layer receives product of input feature with its weights value and is passed as input to next hidden layer and so on. Choosing number of hidden layers and number of nodes for every hidden layer varies with the problem as well as data set. Output layer. At output layer, processing of nodes are determined by the functions called as activation functions like tan, sigmoid, ReLU. Depending on the kind of dataset and criteria, one can decide suitable activation function. Output layer receives the output generated by last hidden layer as input and generates an output in the desired form. For discussions. Machine learning techniques has got prominent role as they are applied in variety of domains, especially in the healthcare. Unlike traditional methods, the models generated by applying ML techniques show dynamic outputs as data is fed into it. One shall make note that significant and narrow research is needed to obtain knowledge in diagnosing the disease. Various machine learning algorithms and techniques are being proposed rapidly, out of which some are observed to be promising with the results and few demonstrated their usage in different fields. Advantage with the ML generated models is that when more data is used, the precision values gets increased and the much accuracy in predictions can be gained. 5. Conclusion. This paper is an effort to present broad review about Parkinson disease diagnosis system that have applied various machine learning techniques. The summary of results obtained by different researchers is made available in literature survey table. Almost all the authors/researchers made great efforts to predict the Parkinson disease with novel approaches. It can be identified that maximum of all ML techniques used by various authors worked better, but developing a very faster classifier using novel architecture of neural network combined with specific approach may work better. To achieve this, we try to implement artificial neural network with different number of hidden layers and number of nodes in future and compare all the accuracies.